Good afternoon, class. Want to talk about 6.3, part 2, area of a triangle. So, I'm sure a lot of people know how to find the area of a triangle already, but now this one is like a different approaches with a different condition for finding the area of triangles. So, we'll take a look at that. So, we're skipping the warm up here. So, given that one angle and two sides, so let's say that back to geometry, we do have a condition like psi angle psi. And normally psi angle psi is the one that we use to prove the congruent triangle. But now this time we're just like using it as a given condition. So let's say we do have a regular triangle. So given that angle A, segment B, and segment C. So normally the way to find the area of a triangle is 1/2 base times the height. So let K represents the area of a triangle. We don't want to use capital A because that capital A is like considered one of the angle here. So one thing that we notice sine of A by using SOHCAHTOA, according to the right triangle here, the one that's highlighted in red, it's hypotenuse over, it's opposite over hypotenuse. So just multiply C on both sides here. So we cancel out the C on the right hand side. So you got C sine A equals the height. So instead of using the height for the right triangle, for the triangle here, so we're using that as C sine A. So we plug in C sine A for the height. So we do have 1/2 times the base times C times sine of A. So anytime they see anything like psi angle sides, so the area of a triangle can be founded like this. Okay, so that's just the short proof, and also can be written as like different kind of form as well. So not only can be written as 1/2 BC sine A, but also can be written as 1/2 AC sine B, and also 1/2 AB sine capital C. So we're going to use the example like this to find out the area of this triangle. So we do have a triangle DEF. So make sure that you draw the triangle first with the label. So triangle DEF. So again, the given condition is considered psi angle psi. The way to read through it, it's either by clockwise or counterclockwise. So psi angle psi. So again, anytime that's given with a condition like that, we can always use that formula. 1/2 times 2 psi's times that included psi of the included angle. So 1/2 times D times F times sine of E. And then by plugging a number, we have 1/2 times 17.4 times 19.7 times sine of 49.6. And now you want to do that on the calculator. So one thing at a time, multiply everything from left to right. Okay, so do that on the graphing calculator or the TI or the scientific. So you got 131 square inches if you try to round it up. So here's another problem that you can try. So also it's given as psi angle psi, so R, S, and angle T. So try to draw the triangle here. So this one, angle T would be the included angle. So that area would be considered 48. So now what happens if that given with two angle and one side? So let's say that we do have angle size or angle side angle. So again, it's just like a regular triangle. So this one is just in general. So given that angle A, segment B, angle C. So once again, the way to find the area of the previous with the area of a triangle with the previous formula. So that's the one. So K, once again, that's representing the area of the triangle. So it's 1/2 times B times C sine A. Again, C sine A, that's just the height. So now, but the thing is that, what about for angle A here? And then segment C. So we're going to find out. So again, one thing that we notice, so angle B, it's 180 minus angle A minus angle C. So this one is based off the Triangle Sum Theorem. So we need to find out what angle B first. So one thing that we notice, sine of capital B over B is the same as sine capital C over C. So we'll deal with that in the future. This one is called the law of sine. So just cross multiply, so isolate that C by itself. So we do have B sine capital C over sine capital B. So instead of using C, we're using that B sine capital C over sine capital B. So that means the formula can be written as 1/2 B squared sine capital C, so things that's on the top, sine capital A, so everything that goes on the top there in the numerator. And the one down in the denominator, we have 2. and then sine of capital B. So this one is actually pretty easy to recognize the formula. So sine C sine A, and then the included segment right between those angle, so that goes on the top. And then the corresponding angle, so sine capital B, so that goes down the bottom. Again, 1/2 is just the scale. It's just like a normal scale factor for finding the area of a triangle. And also the formula can be written like this as well. So A sine capital B sine capital C over C sine A. Or it can be written as C squared sine capital A sine capital B over 2 sine capital C. So this one, anytime that you want to find the area of a triangle with that angle psi or angle psi angle. So now we're going to use that formula to find the area of those triangles. So given that triangle PQR, so angle P is given already, 51.7 degree. Angle Q is 41.5 degree. And then the corresponding segment of angle P is 156.3 centimeters. Okay, so here's what we got. If you just read through the diagram, it's given as angle psi. So again, in order to find out the third angle, we're using the triangle sum theorem. So triangle sum theorem, so that would give you 180 minus 51.7 minus 41.5, which is 86.8. Again, using that formula with that angle psi, the area of a triangle, so we do have P squared. There's only one side length given, so we put that on the top. And then 2 sine capital B, because that angle P is the corresponding angles of segment P. So 2 sine of 51.7, we're going to plug in a number later. And now what else stays on the top here? So sine capital Q and then sine capital R. And now by plugging a number, so here's what we found. So 156.3 quantity squared times sine of 41.5 times sine of 86.8, all over the quantity of 2 sine of 51.7 degrees. And then you just put it into the calculator, just do the calculator work. Let the calculator do all the work for you. So here's what we found. Put in parentheses. So we do have 10,297 square centimeters. So here's another problem that I can try. Again, this one is given as angle psi. So the area of the triangles eventually is going to be 75 squared unit. And here's another way to find the area of a triangle with 3 sides given. So this one would be conditions number 3, side, side, side. So anytime that you deal with this, guess what? We're going to use the Heron's formula. So it's written as K equals square root of the quantity of S. S, which means the semi-perimeter of the triangle. So S times the quantity of S minus A, S minus B, and then S minus C. Again, S, that's representing the semi-perimeter of the triangle. So the way to find out the semi-perimeter of a triangle, so that means A plus B plus C over 2. So which means that's the perimeter of the triangles divided by 2. Again, so the name for this formula is called the Heron's. So it's one of the famous mathematicians for geometry. Okay, so now let's find out some of the problem here. So examples PQR. So given with 3 sides. So first thing that you want to find the semi-perimeter. So combine that PQR all together and then divide it by 2. So here's what we found. So 15.2 plus 22.7 plus 8.9, the whole quantity, divided by 2. So we do have 23.4. And then put it into the Heron's formula. So square root of the quantity of 23.4 times the quantity of 23.4 minus 15.2. And then the quantity of 23.4 minus 22.7. And then the quantity of 23.4 minus 8.9. So once you find out the difference of all those quantity, so all you need to do is just multiply all those numbers together and then take the square root and make sure that you need to round it to the square centimeter. So here's what we found. So it's 44 square centimeters. And here's the last problem you can try. Again, it's given as side, side, side. So it's RST. Again, so using the Heron's formula, and you'll get the area of a triangle, which is 30. Okay, so thank you for watching the video today. So I'll see you guys next time. Ciao.